Hello and welcome back to the channel, everyone. Today we are once again going to be stuck inside of our wave manager actor component here. So what we want to build today is really our start spawning functionality. This is going to be kind of pivotal to everything else that happens. So what we're going to do is we're going to set timer by event. That event is going to be a custom event called handle spawning, which is actually going to handle the spawning. Calculate needs, we're not going to, that's just kind of in the way. Let's put that over there. The time here is going to be, if you remember correctly, when we made our spawner details, we can break this open and we can get our spawn interval out of there. We're going to set this to looping and we're going to set this return timer handle to the spawn timer handle we've been using. And this is that spawn timer. So this is what we've been talking about the whole time. That basically just makes sure that everything is kind of spawning when it is supposed to, and pauses itself based on needs. And we're going to determine some of that right here. So handle spawning needs to run a branch. We need to see if our active enemies is greater than or equal to our spawner details. So we're going to copy this whole break and paste it down here. Our max alive. So we're basically just checking the max alive to see if our active enemies is greater than or equal to that. If it is greater than or equal to that, it should never be greater than, but if it is somehow greater than or equal to that, we need to make sure we're pausing this timer. So we're going to get this spawn timer and we're going to pause timer by handle. Now, if you remember from the last couple of episodes, when we kill an enemy, we unpause the timer if there's still enemies left to be paused. And then I'm just going to print a string here called max enemy so I know what's going on. Now we're going to need a custom function next off of this branch to basically determine the enemy spawn location. So I'm going to make a function here called get enemy spawn location. And for now, we just need to know that this is going to return two variables. This is going to return a vector for the spawn location, and it is going to return a boolean for location failed. For now, that's all we need to know. We're going to implement that in the event graph and build it in a minute. So our get enemy spawn location, if that location has failed, then we just need to print a string that lets us know location failed, will try again on next spawn tick, or something like that. I know I butchered the typing there, but I was just typing it fast. It's like behind my microphone. I can't see it. But yeah, so that's all that's going to happen on get enemy spawn location. If we, for some reason, fail, we want a message. We don't necessarily want to stop gameplay when this comes back around in another second. It's just going to try again. So it's not like stopping the timer or pausing the timer or anything like that. Now, off of the false, we need to handle the enemy spawn. And that is going to be another custom function called handle enemy spawn. And it was just easier to have this as a custom function. It's going to take an input of the at location. And that at location is going to be what is coming from this get enemy spawn location. So off of false, we're going to drag in handle enemy spawn. And we're just going to use this spawn location as the at location. Once that has happened, we have spawned the enemy. We need to take our active enemies. We need to get it and increment it. Because there's one more enemy active in the world. One more enemy active in the world. We also need to take our spawned enemies, so enemies spawned, and increment that as well, because we have spawned one more enemy, okay? We have spawned one more enemy. We need to check and see if our enemy spawn is greater to or equal, greater than or equal to our maximum enemies, so our total enemies for the round. If it's greater than or equal to our total enemies for the round, and we want to make sure here we are not allowing overspawn. So we're going to take allow overspawn, we're going to get the NOS, and we're going to plug that into the AND here. So if it is greater than or equal to the total enemies and we do not allow overspawn, then we need to go ahead and just disengage the timer. The timer no longer needs to be valid. So we're going to take the spawn timer handle and we are going to clear and invalidate it because we no longer want to be using this timer. It's done. We've spawned all of the enemies and we're not allowing overspawn, so there are no more enemies to spawn. And we have completed the job. If that's false, it's just going to keep going until we are at the max alive or until we end the wave and tell this to stop. Okay, so that is all that's going to happen here. We're going to go ahead and comment that, and we're just going to say this is the spawn timer details or something like that. But we do need to go ahead and build out these two functions so we don't get carried away and like lose sight of them. So get enemy spawn location. This is going to be the first function that we build here. This one is honestly not too bad. This one's going to take the spawn pads actor array. We're going to get that, and we're going to run that through a for each loop by dragging out and pressing F, or searching for each loop. We're going to take can use pad. If you remember when we made the pads, when we altered the pads a few episodes ago, we made this I can use pad. If we can use the pad, then we need to get actor location. And we need to make a local array of locations. So we're going to make a local variable. And this is going to be called LOCS. I guess LOCS would work better than LOCKS, but whatever. We just need to know that this is our locations. We're going to get that, and we're going to add a location to that on true. So this is a usable pad. It is not, nobody's sitting on top of this pad. It is active. It is not a boss pad, so it is therefore usable for enemies. And when we're done with that, we're going to run a branch. We're going to see if LOCS is empty. This is our fail, is empty. Because if LOCS is empty, we just need to fail out is true. We're not going to try to get an empty array item and set that, so we're just going to fail out as true. Now, if that is false, we actually need to get an item out of this, right? We need to get a location for the enemy to spawn at. So we're going to run again a random array element, random array item, and plug that right into the spawn location. And that is all that's going to happen here. This could technically be pure, I believe. I don't think this event dispatch stops it from being pure, or this BPI stops it from being pure. But it was working in my project as impure, so that is just kind of how I'm going to leave it. Again, that is get enemy spawn location, so if that fails, that is why we get this string. If that succeeds, then we have a valid place to handle our enemy spawn. Now, handle enemy spawn is going to be a little bit more complicated, because now we are getting into the area where we need all of our maps, and we need all of our keys, and we need to be doing a whole bunch of stuff. So to make this whole system work, we're going to need two maps. One is going to be called enemies for wave, and these are going to get set up when we set up the calculate needs. This is going to be of the type actor, so we're going to search for actor class and make this a soft class reference. This is where soft references are going to be important, and remember, it is a map to integer. So soft class reference of an actor to an integer. And this is just how many enemies are going to be needed for the wave, and we're going to use calculate needs for that. The next variable is going to be enemies to spawn. And we're going to have to use enemies for wave by the current enemy pool to calculate the enemies to spawn. So what we're going to do here is we are going to control drag out enemies for a wave. We're going to use keys. If you've never used a map before, keys basically just gets all of the actor values as an array. We're going to get a random array item out of here, and we're going to see is valid soft class reference, because we want to make sure this is a valid soft class reference. If we try to proceed without this check, there's a non-zero chance we're going to get an invalid reference, and we might end up crashing out the game when we don't really need to, because we can handle that as a fallback right now. So to handle that as a fallback, we can take our spawner details, control drag that out and break it, get a random enemy, because we know if this is empty, something is totally wrong with our game. We've messed something up somewhere. This should never be empty at all, ever. This is the source of truth, right? And we're going to promote this to a local variable, and this is part of why I made this a function. So this is going to be L rolled enemy, and L rolled enemy is also going to be set up here on true. It's going to be set on true, and it's going to be set differently on false. On true, it's going to be set to that random. So you should, I guess, kind of promote this to that variable beforehand, because running this random usually will get you a different random every single time you pull out of it. That's kind of a thing with pure functions, and this random is a pure function. So we're just going to set L rolled enemy now. We're going to see if that is a valid soft class reference. If it is, we're going to carry on with our lives. If it is not, we're going to get a random enemy class and make sure that we are setting that to a valid soft class reference. And then we're going to need to run yet another function called get enemy from pool. So it's going to be get enemy from pool. And this is going to be what gets called to try to get the enemy from pool and activate the enemy. because we are still in the handle enemy spawn when we are literally telling the enemy to get out there. It's your time. You're number one, right? Go catch them. So what we need to do here to get the enemy from pool is we need two inputs, one of the type actor and another one of the type actor. Thing is, this second actor is going to be a soft class reference, and this first actor is going to be an array. Technically, I don't even need to get these or collapse this into a function, but it's just a little bit easier to manage this way. So we're going to call this enemy pool, and we'll just call this in enemy pool. That way we have a distinction. And we'll call this one down here enrolled enemy. We're going to call this one down here enrolled enemy, and we are going to return an output of a single hard reference actor of out enemy, because we have found the enemy that we want to spawn. Okay, that is get enemy from pool. We'll worry about actually building that out in a minute. We just need to know that in the handle enemy spawn, the next thing we're going to do is get enemy from pool, and that is going to happen on both of these. We're going to make sure that we take our valid enemy pool, so the last valid enemy pool. We're also going to make sure that we take this actual reference to the rolled enemy, because we want to make sure that no matter what, we are getting the valid rolled enemy. So if this was true, and we pulled out of this rolled enemy, it would be invalid. It would kind of break, because we never ran the false, so this was never valid. It gets to be a mess. That's why we always grab a clean reference. So get enemy from pool. We first need to see, is this valid? Because if this is returning invalid, that is a problem. You might want to add a break here. Now, if that is valid, we are going to activate the enemy. So we made this function before. It just takes in an actor object reference. So we're going to pass actor into that. And we're going to pass the spawn location as this incoming at location. So I'm going to right click and say get at location. And I'm going to have to scroll down here to get the at location from the input variable. And we're going to go ahead and set that to activate enemies. So now we also need to run a few more things. We need to take our enemies for wave, and we need to remove the rolled enemy from it, but only if we've spawned all of the rolled enemies of that type. So we need to run a little bit more logic here. We're going to also take our enemies for wave here, and we're going to find the rolled enemy inside of that map. That way we can get an accurate count of how many enemies are left inside of this map. So we're going to say -1, and that is basically the new amount. So if that new amount is going to equal 0, then we need to just go ahead and remove the map entry entirely. Now, if that is false, we also need to take these two same variables. The map we are going to add this time. Now, add on a map, I've explained this a few times in other videos, does not add literally the number to the number. What it does is it replaces, if an entry already exists, it replaces that entry. If an entry does not already exist, it adds that entry. So that is everything that is going to happen in handle enemy spawn as well. So that is done. Congratulations. We still can't do much of anything with our game. So I do want to try to get the enemy from pool today, but this is honestly one of the more complicated functions in our system. So make sure you stick with me here. Don't delete that return node. The first thing we need to do is we need to take our enrolled enemy, and again, is valid soft class. If this is not a valid soft class, then we need to do something else. Okay, if it is not a valid soft class, we need to get this in enemy array, or in enemy pool, which is an array of actors, and we need to run a for each on that. This for each is going to get the actor, say get is active, because remember in our BPI damageable, we made get is active to see if the enemy is active. If the enemy is not active, then we are going to make a local pool. So create a local variable called lpool. And this is going to be an array of hard actor references because they already exist. So actor pook? No, not pook. Pool. Anyway, we're going to take actor pool and we're going to add on false. So on false, add to the actor pool this actor. Because we are just basically saying that we don't know what the rolled enemy was. For some reason, it was corrupted. We didn't get a valid rolled enemy in here. We just need to grab a random enemy from the pool that isn't active, because we don't want to like crash the game over this. We just want to make sure we handle it. So we're going to take this. Off of completed, we're going to say is empty. Not this in enemy pool, though. We're going to take this local pool. We're going to say is empty. And off of the completed, we're going to run a branch on is empty. Because if this is still empty after we've looped through all of these enemies, we're kind of screwed, right? So if that is false and it is not empty, we can go ahead and return a random enemy. So we're just going to take this L pool again, and we're going to say random array element, and we're just going to return that. Because we just returned something randomly here. We don't need to worry too much about the actual math of randomization or anything like that. We've already had errors. We're just trying to get away from this gracefully, right? So now, off of the true branch here, we're going to need another branch because we didn't find anything. So now we need to take our spawner details here, and we need to break that open. And we need to make sure that this enemy classes is not empty. So we're going to say is empty. That way we can run the true again. And if that is empty, we're going to print a string that is going to be verbose and basically tell you you're a loser. You might even want to add a breakpoint to this because you have failed somewhere along the way, and you want to make sure that you know you're a failure. Now, if that is false, we are going to run a random out of this because basically there was just nothing left in the pool, and we don't want to stop spawning because of this right now. We're going to do what's called load class asset blocking. We might change this in the future to be load asset async, but we'll decide later on. Once again, we are going to cast this to the actor class, and we are going to spawn an actor from class. We are going to split this spawn transform, and we're just going to get the pool location and spawn it at the pool. We are going to take the enemy pool now, the actual enemy pool variable array here, and add to it. And then we are going to take our return node, wherever our return node may have gone off to. I'll just control copy this one and paste it. We're going to take this return node and return, again, that enemy that we just spawned. So hopefully that makes sense. I wouldn't worry too much about having too many enemies in the pool. Really, this down here should never really be happening unless you like just somehow just have really messed this up at some point. And then maybe add some breakpoints to check some. But most of the time, we should be running true on this branch. So on this true branch, we also need to take in this in enemy pool. Okay? And from this in enemy pool, we need to run a for each with break. Because basically, we are just trying to find the next enemy in this pool that is eligible to be spawned. So what we're going to do is we're going to get class. Just the utility here, get class. We're going to take our rolled enemy, so get in rolled enemy, which is a soft class. We're going to see if that is equal to this hard class. So we're going to take equals, and we're just going to plug that in. And this should see if it's equal to the hard class. Now mine, I actually converted into a soft reference first, or into a hard class reference first, but it looks like this is going to work. So we're going to say and here, because we need to check another value. And that value is going to be the array elements get is active. Because just like on the bottom, we don't want to be telling an active enemy that it needs to activate. It's already active. We're just going to break our game that way. So if the enemy is not active, not active, plug the not in instead of the actual value. If the enemy is not active and it is equal in class to the rolled enemy, then we have found our golden goose. So we are going to promote this to a local variable. We're going to call this L found. And if that is true, we are going to set L found, and we are going to return on out of this. We're going to break. We're done. We found the enemy. So now we need to run some logic on the completed to actually handle the returns here, right? So we're going to take our L found enemy. We're going to see is valid. So drag out of this and is valid. Because if we loop through this entire array and we did not find a valid enemy, then we need to do something else, right? We need to do basically the same thing that we did down here. where we load the class asset blocking, spawn the actor, add it to the enemy pool, and do this stuff. So we're going to control C, we're going to control V that. On the is not valid. Again, that is the load class asset blocking, cast to actor class, spawn the actor at the pool location, add it to the enemy pool, and return out the enemy. Okay, on the false. And where we're going to get this asset class is the same in rolled enemy. So we're just going to duplicate that down. That's going to be our asset class here. Otherwise, if that is true, we just need to go ahead and return. The true is very simple here. We can just go ahead and return the local found because we found the enemy. We're good to go. We will just return that actor class. So hopefully all of that makes sense to you. I know we're getting kind of down into the end of the video here, but I wanted to make sure that everything we've made so far is kind of self-contained and ready to go. We're going to be doing a lot more in the next episode. I know we've got one more episode of this nonsense with the actor component to get through, and then we should be actually spawning enemies into our world and handling our waves and doing all of that fun stuff. Thank you for watching. Consider joining our Patreon. For just $3 a month, you'll get instant access to all of the project files and the videos as soon as they come out. Now, on to the next one.